Don't you wish we could prioritize wireless applications just like we can on the wired network? Well, now with 802.11ac exploding on the scene, it's not like these networks are getting any smaller. So why hasn't this been done already? Well, it's just not that easy. I mean, most wireless deployments require tunnels or other design features that mask the detail needed for this kind of control. I mean, to have QoS on a LAN switch, maybe it should just be a LAN switch. Yeah, that's an idea. Stay with me here. So what would that look like? How about, okay, easy troubleshooting and visibility, consistent security and controls, reliable, redundant, has to scale, of course, and we gotta have one platform for both wired and wireless. You know, it turns out we did make that list. We locked our engineers in the lab, pumped in plenty of Star Trek episodes, and said this has got to happen in hardware. Now, when they emerged, they had created Converged Access, the unification of wired and wireless into a single distributed data plane. Oh, and that hardware bit? Running in hardware brings in more than just faster lookups. It means ACLs, QoS, span, and even flexible NetFlow, all made possible through a brand new custom ASIC optimized for that next generation network operating system, iOS 15. Now, they did all this not because they could, but because they should. Unification on iOS allows wired and wireless features to coexist harmoniously. One operating system means easier upgrades, common scripts, only one CLI. It's a zen of simplicity. Hey, you ready to solve some wireless problems? First off, don't overthink it. It's a network switch with a wireless controller built right in. Simple, all right? But oh, how that does change everything. Roaming is now handled inside the switch itself. This means all policies, QoS, management and visibility, configured and managed once. 802.11ac is already here, and that's just one example of the scale you can expect. 480 gigabits of stackable form factor with stateful redundancy like NSF and SSO. Okay. Two very important roles your switch now plays. First is the mobility agent, which maintains a database of locally connected clients per stack, and with CapWAP tunnels now terminating right on the switch, this is huge. Now add that 40 gig backhaul, and you don't have to force that tsunami of wireless traffic through a centralized controller. Coordination tasks like roaming and radio resource management are handled by the second role this switch now plays, mobility controller. Watch. Hey, we take the mobility agents and we logically divide them up into switch peer groups. This is based on stuff like floors or building identifiers. Inside this switch peer group, all roaming is transparent between layer 2 and layer 3, so right away, they're all fully meshed with each other. Each switch peer group is assigned to a mobility controller, a collection of MCs we call a mobility group that handles all the key distribution. Fast, resilient, simple. And when your wireless LAN gets a little bigger, as they are wont to do, intermobility group communication and management is just a step away. Voice over IP users can now communicate seamlessly with quality and policy parameters intact. But that's not all. These things are only growing, right? Full-featured, iOS-based quality of service has arrived for wireless, and not that generic software-based stuff either. This is ASIC-based granular QoS that really realigns the dilithium crystals to make you a miracle worker of mobility. Visibility and control deep into the wireless traffic without those wired and wireless distinctions, okay? Heck, you can even use tools like flexible NetFlow now. Carve out virtual queues, allocate fair bandwidth usage no matter what SSID they use. All that with one policy? Now that's simple, right? One policy, one management, one network. Hey, wired and wireless converged. We're not talking about marketing promises here. We're talking deployment reality. This is how you do networking. Get more information on this as soon as you can.